Welcome back, Physics 30. So this is the last part of this question. We kind of started off by looking at, for elastic collisions, deriving a new relationship here when it's elastic by looking at kinetic energies and momentum. It involves using this if we know it's an elastic collision. So now we're just going to substitute everything in here and solve. So MA is 0.45, and it was moving to the east with 5.8. And my second was a stack of 2 pucks, and it was not moving. And then my mass of A, and I'm looking for what is it going to be moving after it collides. And my big mass of B, and then this part right here, VA was 5.8, oops, minus VB, guess what, that was 0, wasn't moving, and then V prime A. So all what we have to do here is figure out isolate VA prime, and we'll be able to figure out what that number is. Now this part here, of course, is 0. And then over here, 0.450 multiplied by 5.8, 2.61. 0.45, look how simple this equation comes. So this is going to be 0, so 0.9 times 5.8, and then 0.9 multiplied by V prime A. So if we have 0.9 times 5.8, 5.22, and then 0.900 V prime A. And of course we can combine these, take the 5.2 to the other side. And then combine this. 0.9 plus 0.45 is 1.35 V prime A. And then 2.61 minus 5.22, negative 2.61. Oops. And then divide by 1.35. And V prime A, the velocity of A after is going to be 1.93 meters per second. So it's like we have our one puck here. It's going this way. Our stack of 2 pucks is doing that. There we go. Now it kind of looks like 2 pucks. So before and then after, my A puck is going to be going this way. So the big question here is what happens to that stack of 2 pucks after. So all I have to do is plug it into here, because this is the relationship if it is in fact an elastic collision. So VA minus VB plus V prime A. So again, I'm just, oops, I guess I should show you what I'm doing here. Just pulling that for elastic collisions, the relationship between all those velocities. So V prime B, so my VA, of course, was originally moving at 5.8. VB was not moving. And my V prime A is 1.93. So V prime B is 3.87 meters per second. So my big stack here will be moving this way. So before, this puck's moving, this stack is not moving. After, it's almost like my first puck rebounds out backwards and my stack moves to the right. Okay, so that's the key thing. You're not going to have to know how to derive this equation here. You just need to know that for collisions, conservation of momentum applies. If it happens to be elastic, that means total kinetic energy before equals total kinetic energy after. Combining all these equations, we get this relationship here compared to initial velocities and final velocities. Again, only if it's an elastic collision. And of course, the types of questions we can look at here is solving for what's happening after if we don't know either one of these. And on the assignment, I think I have 2 questions involving this, in which you have a before scenario and an after scenario. The after scenario, you have to figure out the velocities, and of course we do that by using this little velocity equation for elastic collisions. All right? We'll see you again.